सर ऑडियो ऑडियो नहीं आ रहा।
ओके।
वॉइस शेयर नहीं हुई सर शायद।
वॉइस नहीं आ रहा है।
हाँ, वॉइस शेयर नहीं है सर, वॉइस का
ओ माय
कुछ।
बताए। लेट मी चेक। नाउ।
नो सर। यस सर, अब आ रही वॉइस आ रही है।
ओके। बस सर, शुड वी स्टार्ट?
Yes, sir.
ओके। मधुमिता मैम, नाउ ओवर टू यू मैम।
Good evening, everyone. I, Madhumita Gupta, welcomes you all on behalf of IAC, IET, and Applied Science Department of Sage University, Indore, to the third day of this enriching faculty development program. Yesterday, we witnessed around 150 faculty members engaging discussions and valuable insights. Today, it will be more engaging interactions and greater energy because our keynote speakers are Mr. Ali Asgar, Senior Fabrication and Paint Shop Quality In Charge, CNH Industrial, Pitampura Area, India, and Dr. Devendra Verma, Professor, IET DAVV Indore. Now, may I now request respected HOD from Mechanical Engineering Department, Dr. Rupesh Tiwari sir, to welcome our keynote speaker.
Thank you very much, madam. Very good evening to each and everyone present over here. I, Dr. Rupesh Tiwari, HOD Mechanical Department, Sage University, Indore. Heartily welcome our today's speaker, Mr. Ali Asgar sir, Senior Fabrication and Paint Shop Quality In Charge, CNH, Pitampura area, to deliver his session on the topic Sustainable Manufacturing Practices in Electrical Vehicle Production. So I heartily welcome you, sir, for this nice session, and we will definitely gain something from your session.
Thank you.
Thank you, sir. Over to you.
Uh,
Thank you. Thank you.
sir,
I'm going to share my screen.
sir, before
Over
starting,
to over to Satyan, sir.
yeah, sir, I would like to give your introduction. Uh, so let me allow for this. So, dear participants, our today's speaker, Mr. Ali Asgar Devaswala, is a seasoned manufacturing expert with 16 years of experience in lean manufacturing, production, quality, and engineering. He is currently the chief lean practitioner at CNH India Private Limited, Pithampur plant, where he specializes in optimizing processes to maximize efficiency and reduce non-value added activities in fabrication, painting, assembly, and PDI operations. With a mechanical engineering background and post specialization in fabrication processes, Mr. Asgar has led numerous initiatives to streamline manufacturing, improve productivity, and lower costs. His session will provide valuable insights into sustainable manufacturing practices in the EV industry, leveraging lean methodologies to enhance operational excellences. With these words, I request Ali sir to start the session, sir. Now over to you, sir. And
Thank you. Thank you so much. My
I
voice
would
is
like to,
audible to.
yeah, yes, sir, perfectly, sir.
Okay, okay.
I want to thank once again because you accept our request on a short notice and allow for this session, sir.
Thank you. So, shall I share my screen? I have prepared
Yes,
a small presentation. Maybe anybody can ask the question if they have some doubt and understanding in any of the facts and figure. I have used some of the facts and figure from the Ministry of Science portal, and all these are with the help of different uh, magazines, especially, which is very crucial for us to understand where we are and where we want to be. So, with due respect, I am sharing my screen. Please confirm me if my screen is visible, Satyanji.
no, sir, yet not. Just click on, yeah, yes, yes, sir. Now it is shared. Perfect, sir.
So,
There is,
benchmarking activities, which is, yeah.
sorry to disturb, sir. Actually, voice थोड़ी देर के लिए missing था.
Okay,
Maybe due
okay,
to network issue. Yeah.
okay. Now it's well connected.
Yeah, yes, sir. Perfect now.
Okay, thank you. Please tell me if my voice or my video is, or shall I close my video if you permit? Because
It's up to you,
sharing
sir.
the sharing the screen may be a hurdle a little bit. Okay,
Okay, no
thank
issue,
you.
sir.
So, hello all. I am Aliasgar Devaswala. I am a chief lean practitioner in the CNH India Private Limited. I have having the experience of 15 years in the field of process implementation in the manufacturing. Basic knowledge of the manufacturing starts from the value adding activity. So there are a lot of non-value adding activities in the manufacturing. Uh, my department and my job in these organization is to identifying the non-value adding activities and eliminate those activities. So basic basically we are looking for the
Sir, voice disconnected actually.
now it's clear.
Yes,
Yeah,
now it
okay,
is
okay.
clear.
So I'm at the point of the non-value adding activity identification, and we basically benchmarking our processes in all over the globe, and with the limited resource we want to produce more and more efficiently and cost cutting of the processes. So I'm quickly go through the my presentation. Presentation mode. Now it's visible all or
Yes, yes, sir. It was already in slideshow mode. Now your next slide is also visible. Two
okay,
slides we
just
can now see. Previously it was on in, yeah. Now it's
so basically Case Construction Equipment Private Limited is the subsidiary of CNH Industrial. We are the leading player in the Indian market within a state-of-art manufacturing facility in Pithampur. So we are basically in the business of producing the construction equipment and agriculture equipment. So we are the global leader also in the earth moving equipments. In Pithampura, we have established this facility in 1989. And our production facilities is spread on the 1,62,000 square meter area. If we talk about the history of the case construction, so we have established at 1842 by J.I. Case. And first backhoe loader we have produced in the year of 1842. We are committed towards the sustainability also. In Geneva Convention, there is a sustainability model is given. So we are committed towards the that sustainability model. So we have started our electrification from the year of 2016. Later slide we will cover this information also. In 2024, we expanded the skid steer production also in the Wichita, that is placed in the USA, to Pithampur. So now Pithampur plant is basically having the 4 model lines, and they are producing the 7 type of variants across the world and supplying all over the globe. Almost 120 country we are supplying. So it's just an introduction first about what and which background I am, and then we'll come on the topic of today's topic. So
okay, sir.
there are 2 lines. One is the heavy lines in which wheel loader, crawler, excavator, grader, and dozer we are manufacturing. And in the compact line, where the loader backhoes, mini excavator, then skid steer and compact track loaders, we are manufacturing in the plant. So these all are the manufactured by the CNH, designed by the CNH, and serviced by the CNH. Wholesale from the start of the product life cycle to the end of the life cycle. So we are present in all the 7 plant location. In USA, we are at Fargo, Wichita, and now in Burlington. In South America, we are at the Belo Horizonte in Brazil. In Europe, we are at Lecce, Italy, and San Piero in Italy. And one plant in APAC region is at Pithampur, Indore. Little bit history about the Indore. We have established, I already told you that we have established in the Pithampur plant in 1989. And it's having a 4 basic model which is rolled out from the Pithampur plant. So we start with the why electrification matter for us, because it's a user experience which reduce the noise and better operability. The fossil fuel is one of the key factor for us that which is depleting over by years. And the regulation user preparing for the emerging regulation. So we are not building EVs because the trend or social pressure. Our reason is more fundamentals. And that is exactly the same reason that every other case machine since 1942 to meet the changing need of our customer and help them to get more done and less on the less feet. So the efficiency is mattering. The carbon emission is matter for us, and we are also committed towards the society. If we just looking on the our models which we have rolled out from our Pithampur plant from CNH Industrial is first biomethane tractor that is almost a net zero impact on the emission. And then this is first backhoe loader we have rolled out with a 90% lower operating cost than the diesel operated backhoe loader. So whatever the R&D, whatever the best practices we are discussing in the forum, we use these best practices to manufacture the loader backhoes or our construction equipments. There are some few examples on agriculture side and the compact side where we are, although we have started our commercial manufacturing on these models. So basically, we are having the 4 models in the which is already electrified out of the 27 model which we are manufacturing all over the globe. In agriculture, we have the 12 basic models which is electrified over the 50 models. So yes, we have to work hard to produce more model in the electrification to offer our customer 100% than the right now what we are at 20% and 30% the model. Our journey has started from the 2006 when we produced the first New Holland clean energy wheel loader, and then fuel cell hydrogen tractor we have worked out on the 2009. So if you see, then the electrification models has been developed, and now in 2020, we have produced industry's first fully electric backhoe loaders. So in year of 2022, now it's 2024, we are commercially producing and selling these units. We have already talked about the features of the 580 EV. That is our dream project for the plant, and the same our path to zero carbon in the agriculture. Now coming back to the our presentation, I'm moving on the core area of what is required in the brief introduction. So what is the electric vehicle? Everybody knows that the electric vehicle is a vehicle which is operated by electric battery. An EV that draws electricity from a battery and is capable of being charged from an external source. Now, an EV include both a vehicle that can be only be powered by electric motor and that draws electricity from battery, and a vehicle that can be powered by electric motor and draws electricity from a battery and by an internal combustion engine like a plug-in hybrid electric vehicle. So there are four types: battery electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle, and fuel cell electric vehicle, which I have shown you in early slide. The hydrogen-based model is a fuel cell electric vehicle. So we have a model on fuel cell electric vehicle, as well as we have model on the plug-in hybrid electric vehicle also. So these are the 6 reasons why we required an EV in our diesel portfolio or on the fossil fuel portfolio. So fast depletion of the fossil fuel is a main and foremost reason, followed by the reduction in air, the percentage carbon emission percentage, carbon dioxide emission percentage, and need of the hour to serve everyone, because this earth is limited, the resource of the earth is limited. We can say more than 80% of India's population, we live in highly vulnerable to extreme hydromet disasters. So this is also one of the biggest reason that how we are changing our climate so aggressively, and we need to reduce our carbon footprints, and also the facility to employment growth in a sunrise sector. This is one of the area where every country has put their feet up, and we also want to be in this business. If we see the EVs in India, then India is a following country. It's not a market leader. So our penetration is only a 17% of total sales of the automobile. So thanks to the EV Reporter magazine, who published this one of the good report, I have taken one of the good data from this magazine, and this shows the indicator that where we are. So on these line, or a blue line, the electric vehicle market penetration, which is shown, is only a 17%. So what is our target? Our target is to be at least 30% by the year of 2025. And if we take this data of Department of Science and Technology, they have the target up to the 2070. They have to be 100% market of the electric vehicles. So our government is pushing towards the shifting of paradigm from the fossil fuels towards the EVs. So budget 25, everybody has seen, like finance minister has announced too much relaxation in on the raw material and processing of the raw material. Uh, they have down the surcharges to make the EVs boost, and the cell manufacturing units and the EVs manufacturing unit in the on the lower side of the tariffs. So our target is very clear. India has established the objective to elevate the proportion of the electric vehicle sale to 30% in private cars, 70% in the commercial vehicle. We are in the business of the commercial vehicle, case construction. So this is a very stringent target for us, that we have to be working more precisely to offer these to our customer. And 40% in the buses and 80% in two-wheeler like two-wheeler and three-wheeler by the year of 2030. So this equates to an ambitious objective of 80 million EVs on Indian roads by 2030. So this is one of the toughest target. Right now, as you know that key companies who is working in the EVs business is Hyundai, Maruti Suzuki, Tata Motor, and Toyota. So this is something automobile sector. There are some more in the two-wheeler and three-wheelers, and in buses also some key players now in the market who is launching their vehicles on the road. And major industry players are striving to improve the electric vehicle charging infrastructure also. Like Hyundai Motor India is enhancing the accessibility to electric vehicle nationwide, expanding its ultra fast electric vehicle charging network with 11 new stations strategically located in the cities, including like metro cities. We can say Mumbai, Pune, Ahmedabad, Hyderabad, uh, Gurgaon, and Bangalore, like this. So they have covered the highways also, on which they have put it the infrastructure of fast charging. So along with this, government by the support of the government policies, they are also working. If we see the outside of the India, then this data is of 2024. This is the first half of the 2024. So if you see the different competitors who are supplying what. So BEV means a battery electric vehicle, and PHEV means plug-in kind of electric vehicles. So BYD is surprisingly put it more and increasing by these plus 26%. And if you see the Volkswagen Group is also rising. Volkswagen along with the Auto, they have rise by the 68%. So some of the small player also in the we can say in this group, who is by the help of the research and development, they are putting more fit outside of the globe and producing and selling more and more electric vehicles. So almost 14 million new electric cars were registered globally in 2024, and bringing their total number on the roads, if we equate, then it will be a 40 millions, closely tracking the sales of forecasting from 2024. So electric car sales in 2024 were around 6 million, which is higher than 2023. So there are good players who is working on the R&D, and they put down the cost of their main heart of this electric vehicle, that is the cell, lithium ion cells. The electric vehicle are generally eco-friendly and alternative to the traditional petrol. So, what is the challenges we are facing in Indian AV industry? So, electric vehicle are facing, one is the on-road price of electric vehicle and expensive batteries. So, overall cost is a major charge. I have put it some of the points. On-road price of electric vehicle. One of the primary challenge for transition from to electric vehicle in India is the overall cost. Electric vehicle tends to have a higher upfront cost compared to the conventional internal combustion engine. As you know that the two-wheeler cost of with a petrol engine is costing around 60 to 70,000. Meanwhile, if we go on the lower segment, then the electric two-wheeler is ranging around the 1 lakh and 1 lakh 10,000. So this cost difference is the major hurdle, and the cost differentiation is coming from the electric cells, the lithium ion battery. So the expensive battery is the major reason major reasons for the electric battery is the major reason for this cost high. So these batteries account for a substantial portion of an electric vehicle overall cost. Although battery price may have been decreasing over the years, they also still constitute a significant expense. An expensive battery contribute to the higher. We on the next slide we will just see what proportionate is distributed over the costing of these uh, on the battery. Then the charging infrastructure. The charging infrastructures, the availability of a robust charging infrastructure is a vital for the widespread adoption of the electric vehicles. In India, the charging infrastructure is still relatively underdeveloped and very limited. We can say almost the requirement is at least 20,000 stations on the national highways. And right now we are at only 1,000 and something 600 and 700. What I have remember the figures. So this is the scarcity of the charging station condition in India. So the the government policy now boosting to put it and making the subsidies. On the later slide we will understand what the government policy is helping us to putting the charging stations on the Indian roads and make us um, a subsidiary kind of thing, so that if somebody want to put it their fast charging station, they can they will help by the departments. Then another is the one of the challenges in Indian industry is the range anxiety. Whenever you purchase an electric vehicle, you came to know that the range of particular electric vehicle is only 100 or 150 or 160 kilometers. So this will be a big hurdle, because what we are offering right now on the Indian scenario, uh, that will be one of the challenging factors, because we are not having the infrastructure on the road. So when we one body want to go at one place to another place, that particularly they will face the issue from one place to another place. The range of this one place to another place should be less than what they have the range of their electric vehicles. And after all, the last one is the changing the mindset of the customer, that is adopting to the new technology. Whether battery is having the issues, the serviceability is quite expensive or not. So these are the some of the lack of understanding in the mind of the consumer. So this is the one of the good graph I am taking from the Goldman Sachs report. This categorize the value of the battery in dollar with a per kilowatt terms. So in 2019, if we just see the graph of 2019, it's almost $160 per kilowatt, which makes our vehicle or our electric batteries more expensive than ever. It will reduce by 2020 and 21, but by the post-COVID effect, it will again rise in 2022 and 2023 in the same level what we are at the 2019. So the global chain disruption, the Red Sea issues will make again back to the path where we are in 2019. 2024 is the one of the good year in which a lot of R&D work has started. A lot of R&D work has been established by the key players, like in the General Motor, who is researching the lithium metal battery chemistry to increase the range. Because in the previous slide, we understand how the range anxiety is playing a very important role in selection of the electric vehicle. So everybody is asking, आपका गाड़ी चलता कितना है, एक इलेक्ट्रिक व्हीकल फुल चार्ज पे कितना चलता है. So this is one of the area when the General Motor has already doing the research to increase the range with a compact design of the lithium metal. One of the good startup in the China, Goshen High Tech, is also plan and working on the LMFP battery by 2025. So this is one of the good compact battery which produce power in a lower, we can say, dead weight of the battery. Toyota is also developing the new battery technology in given in future, which is ranging is 1,500 kilometers. So if we just come on the next slide, I am just over coming on this slide of the government initiative. This is my favorite slide of cost breakdown of a battery or so 19% is utilized in the production or assembly of these battery or treating of these battery from the raw material to the finished good. 9% is the overhead, and the 72% is now expanding into the direct material cost. If we further bifurcate the 72%, then we analyze the cathode is very expensive, and that is almost bearing the 44% of total cost. Separator and anode is consecutively 17 and 15% approximately. Then coming to the electrolyte, which is just around 10%, followed by the housing, which is 9%, and then some other stuffs which is used is contributing the 5%. So the cathode become most of the expensive item in the battery, and most of the R&D work is going on to slush down the cost. If we go by the basic production system of extraction or mining and refining of the raw material, then the material processing like cathode, cobalt is the most precious element which is used in the cathode. Then anode active materials like graphites we are using. So these are the categorized into the three different region we called as a upstream, midstream, and a downstream. In downstream, we are working what we as a commercial offering of the product, we are working on the downstream. The upstream and midstream still lies in the certain part of the globe. So China is the leader of upstream and midstream, and also followed by the downstream. Some of the portion in India, we are doing the downstream actions. Otherwise, the all these midstream and upstream is not. So this is again one of the good challenge in India, which we are facing as a battery production in the Indian scenario. So this is production steps. Everybody, it just a refreshment for all of them. How we are extracting, how we are doing the slurry mixing of uh, the raw material, active material, binder, and conductive agent, and other additives are mixed in a specific mass ratio. So then it will be coating and drying, and followed by the calendaring, then cutting process, and then we put on the foils of separator in the cell assembly, and then the packaging and electrolyte filling. So the cell are placed in the dry room and electrolyte is injected. So the India needs to focus to boost on electric vehicle industry. We required a strong research and development, uh, especially in the field of the midstream and upstream, because the downstream we are already covered in India, but this is the four field where we are struggling very much. So uh, the institute like you is playing a very pivotal role in the research and development, and the charging infrastructure which should be rapidly developed, uh, followed by the young talented engineers and researcher will be participate into this, and doing uh, their uh, their expertise into the find out the best solutions, especially the cost cutting down of the electric batteries. So the growth is definitely there in electric car market. In 2023, we have sold 19,000 units. In 2024, we are at the 30,000 unit approximately. And in 2030, we targeted to the 4 lakh and 30,000 units. So the Indian electric vehicle market is going to grow dramatically in the coming years. Annual volume also reach as high as the 10 million units by 2033. And we will be having a double fold, triple fold kind of the growth into this. So basically, the our finance bills is get reduced in purchasing or extracting the crude oil, especially from the Middle East, Russia, and African countries. So we can save up to the 8 lakh crore on the import of the crude, and it will be having a clear cut shift from what we are, and uh, we will definitely serve our nation toward this. The infrastructure development will be the key. The best part that would lead the widespread the EV acceptance is the robust charging infrastructure. The present scenario, we have a lot of problems in performance of the battery. The weight is the main key, where we are having the heavy battery on per kilowatt. Now we want to reduce this by any means. Like In our 580 EV, we are using the 500 kilogram battery just for the power of 84 kilowatt. You can imagine for 1 kilowatt, we are expending a 5 kg battery material. So this will also increase the dead weight on our vehicles and will reduce the efficiency. The Indian government has played very important role in pushing EV adoption across the nation. FAME, if anybody will hear about it, the phase one and phase two have boost the initial. So I'm going on the back of the slide where I have talked about the government policies. Just a minute. So FAME is launched in the 2015 where in phase one there is a scheme for focus on the generating demand and advancing the technology piloting project. And in phase two, which is started in the April 2019, where government has put almost 10,000 crore, which is focusing on the public and shared transport electric vehicle like buses and all this. So another scheme is a PLI scheme. PLI scheme is for automotive sector, which is launched in the September 2021 with a budget of 3.1 billion, and its aim was to enhance the domestic manufacturing of the automotive technology products. In electric mobility promotion scheme, which is launched in the July 2024 with a total budget of the 500 crore. It aims to enhance the green mobility and encourage the electric vehicle manufacturing in the country. So there is one more scheme which is launched in the year of 2023 about the battery swapping policy. The government introduced the battery swapping policy, the initial draft for the policy, which is came in the 2023 February. Other government initiative like the exemption from the custom duties of the import, which is effective from the 2023-2024 budgets. Commercial and private battery operated vehicle receive the green license plate and are not required to obtain the permits. So this is one of the red carpet government has put for the electric vehicles, which boost our our kind of the manufacturer of the commercial vehicles also, in which we are having the almost 10% of the road tax, then other taxes. So that is although weave off, getting weave off from these while we are selling to the customer, and as the customer goes to the RTO for registration. And then GST reduce. This is one of the great thing has been happened in the industry, while the GST has revised to the 5% from 12% on the electric vehicle, and charging station also the service charges reduced by 18% to the 5%. Then the road tax waiver I already covered. So this is one of the slide which I have again go on the back to just explain you the how government of India is boosting us and pushing us towards, because they have already targeted for the 2017, they have targeted for the 100% electric vehicles. Then in 2013, 2030, they have a 30% CAGR from the 16% of the penetration right now, what we have the value. in the current market scenario. So we understood the breakdown of the cost of the electric battery, which is the most expensive item in the electric vehicles. Then we understood about the production, battery production value chain, upstream, midstream, and downstream. Then what are the production processes involved in battery manufacturing? Uh, then we have already covered this slide of what India needs to focus on the boost EV industry and what is our future aspect. Now, what is the benefit? This is although we have covered, but we want to go in detail just to promote in each and every segment, not only two-wheeler and three-wheeler segment, or not only on the four-wheeler segment, but on the commercial vehicle who is used in the transportation, which is used in the transportation, which is used in the uh, agriculture field, which is used in the construction equipment. So this understanding of electric vehicle is required, that what is the benefit of the electric vehicle over the internal combustion engine vehicles. So first and foremost is the low maintenance cost. So low maintenance cost, yes, because EVs are typically have lower maintenance and operating cost um, is very much lesser than the electric internal combustion engine vehicles. The reduction of maintenance and repairs is basically in reduction of the moving parts, because we have replaced all these engine facilities into the just electric motor. So and electric motor is basically operating on the principle of the electric energy to the mechanical energy. So the driveline problem will be there, but the noise side, the engine side, that maintenance cost gets drastically reduced. When comparing electricity cost to the fuel cost for the vehicle, there are we can say several important factors to keep in mind. Like one is the cost per mile or cost per kilometer. So EVs, which is used, is generally more energy efficient than the internal combustion engine vehicle. The cost of electricity per mile or per kilometer traveled in typically lower than the fuel cost of the internal combustion engine vehicle, because the EVs travel farther than the same amount of energy they offer. We know that the efficiency which is coming from the petrol engine is only 16 to 17%. So, which is also the next one is the low running cost. So, electric vehicle efficiency is just touching around 70 to 90%. Almost the driveline of the vehicle get impact of reduction of this efficiency. So third point is the convenient charging at home. So this is one of the good benefit that everybody in the passenger cars, they put the vehicle on the charging in the night, and they got the complete charge in the morning. So this is one of the good benefit, and EVs is having a no noise of their own. The EVs are working silently. Then comfortable cabin and more storage option, because we have reduce almost uh, all of the like internal combustion engine is uh, acquiring the more area. In petrol engine, we have a fuel injection system, then the exhaust system, so that all gets vanished from the particular electric vehicles. So this is also one of the good thing where we remove all these serviceable parts to lower down our maintenance cost and increase the efficiency of the particular electric vehicle. So that will give the more comfortable cabin and more storage option is available on particular electric vehicles. At the last, I can say India's electric vehicle revolution is not more a dream but increasingly real at a time when the world electric vehicle market is projected to touch more than the 2 trillion by the 2030. India is gaining the momentum right now and becoming one of the leader in the pace. Although right now we are not the leader, we are coming if we show you the country wise bifurcation. So China and Europe is the leader of this particular segment. We are maybe in mid of the after China and Europe, we coming on the third and fourth numbers. So Indian government policies such as PM e-drive schemes, along with the investment in the subsidize, lowering tax, and more emphasis on the infrastructure development, will see our EVs market emerging on the road in the coming years. This focus on making electric batteries and semiconductors domestically in India will be very crucial and to keep the momentum of the Indian EV industry going. So, association with the global partner and further local supply chain development will reduce the cost of manufacturing even further and help India reach its ambitious target. So the future of India's EV industry is very much on the progressive path, and definitely we will on the right direction. Thank you all to listen me very carefully and passionately. If anyone has a question, so they can ping me. I'll be there to answer you.
Okay, thank you, sir. So I request participants to please unmute yourself if you have any question. Yeah, Amit sir. Okay. Uh, yeah, Amit sir. Uh, sir, your voice is not coming. Uh, First, you need to unmute yourself, sir, please.
Yeah, Mr. Amit.
Uh, Sir, from your products, what is the maximum power of electric vehicle?
Okay. So we use right now the electrification in two category. One is the
Yes.
in agriculture and one is in the construction equipment. In construction equipment, the basic model is the tractor loader backhoe. So we are using the power of 84 kilowatt. I have mentioned this 84 kilowatt. I am just sharing one of the good literature I have.
Okay.
Uh, I'm just opening. It's a PDF file. So, uh, so 84 kilowatt power is now generated. Sorry, I need to share my screen.
Yes. So 84 kilowatt for tractors.
So this is one of the tractor loader backhoe we are offering in the market, which is having a name of 580 EV. So this is with 85.5 kilowatt of total battery capacity. With the nominal battery voltage is 400 volt approximately. So charging time is also 4.4 hour is very much sufficient. And we are providing the swapping of the battery concept. So that because we call this machine like a running horse. So we don't want to be customer to be waited till the next charging. So we provide a kind of swapping of the battery. So one battery gets charged, and in meantime, that particular electric vehicle is getting used on the field for doing the activity. And when it gets discharged, the battery gets again swappable. And discharge battery goes on the workstation to get it charged. So in the normal operation, we can say the average operation of digging, it will be around 5 to 6 hours backup. So the charging time, what we are designing this product is the charging time is always lesser than what we are expecting the work from that charged battery.
So for swiping, how many stations you are providing, sir?
So it's a two station. In the electric vehicle, there are two pockets. One is for the uh, charging unit, and one is the extra battery. Okay. So one particular battery goes on the station. The station is might be your office, where we can plug with the power supply. That
Okay.
power supply, that power supply required a domestic kind of the charging plug-in. So
Okay.
it's a charger who makes it the fast charger.
Sir,
Sir,
there is
one
question.
question.
Yes, sir. Please unmute yourself.
Uh, uh, may I audible?
Yes,
Yes,
yes.
yes, sir.
Ali sir, one question is that presently in India scenario, the selling of EV vehicle is less due to the cost. So in future, is there any chance to get cost reduced than that IC engine? Is there any possibilities there or not?
Yes. Yes. On my presentation, I have given the scenario where we are working on per kilowatt cost of the electric battery. So that particularly per kilowatt is coming around the $160 right now, 160 to
Hmm.
$130.
Yes.
Until and unless it will not reduce to the $40 to the $60, then we cannot be selling these electric vehicles on the cost of the internal combustion engine.
Yes. Yes.
But right now, we are selling the electric vehicle on the basis of the first, first and primer cost of the vehicle and the running cost. So
Yes.
we took the two criteria in mind that the running cost is almost zero. Almost
Hmm.
zero
Hmm.
means it's having only a service kind of and consumable which is using like grease
Only
and
purchase
all.
cost is matter for only purchase cost is more. Running cost is almost
So
zero.
that also lower down to the internal combustion engine when our battery cost will reduce to the around we can say $60 per kilowatt. Right now
Okay.
it's very inflated to the 120 to 160, and I show you the cost breakdown, the major contributor is the precious metal is used. So that is one of the limitation. In cathode, now the work is going on, and we are replacing the precious metal like cobalt to the another metals. So this is one of the hurdle that we are still using that particular and in this field, yes, we required some of the research so that that particular we can say some solutions come up front, and we can lower down the cost of
Yeah,
the total
definitely.
bill. Thank you.
Definitely.
Thank you.
So there is one more question from Dr. Sharan. Dr. Sharan, please unmute yourself. Sharan sir, are you there?
So, hello, sir. Whether I am
Yes.
audible?
Yeah,
Yes,
perfectly.
yes, yes,
Sir, good
Sharanji.
evening. Good evening, sir. You
Good
have
evening.
given very informative session. Very good. My question is regarding what is life of electric battery, which is used in reactor, and what could be its cost. Also, extending this question, are electrical vehicles better for the environment? If how you are going to address battery disposal issues, sir?
So, Sharanji, thanks
Sharan.
for this question. There are two things. One is the first, your question is about the what is the life of the battery. We recommend right now 5 year is the good average life of the battery. Uh, and with this confidence of the 5 year, we are offering at least 3 year and 3,000 hours warranty and free replacement uh, of whatever we are using in the electric battery. Second thing, we took this battery back. We are having some of the offers. We are not putting this on the dispose of this battery. We again sell out these batteries to the our midstream industries to reprocess and recycle. So one good of our R&D center, which is located at Wichita, is working very keenly to dispose of, or we can say recycling of the chemicals which is put inside of the cells, electric batteries. So like cobalt, which is very precious. So the cathode part is getting extracted again and get reused. Now we are working on the electrolytes also get reduced by somehow, not 100%, but with the same amount or after some of the processing, it can be again used commercially on the new batteries. So there is no need to be uh, means thrown off all these battery and make the environment polluted, because it will again question mark on our sustainability model, because we are also committed towards the environment. So good work is going on, and might be in 2020, 2030, we got some good solution to commercially recycle the electric batteries and especially the electrolytes. The electrolyte, which is used by the lithium ion and nickel. So these are the some of the hazardous waste which goes into the environment again. So if we can protect from this, so it will be a major milestone in the EVs.
Okay, sir. Thank you very much. Thank you, Satyendra ji, sir.
Sir, thank you.
Asgar
Welcome,
sir,
sir.
thank you.
Sir, there is one more question from Mr. Rajesh. Sir, you can, yeah, please, please ask your question, sir.
Hello, Dr. My question is, how do temperature variations impact EV battery performance, and what solutions are there available which are existing today, and what R&D is required regarding this domain?
Uh, so we put some of the sensors inside the battery. Uh, Whatever our principal suppliers, they have offered some of the solution so that if it will cross the threshold temperature, then the operation will be cut off, and immediately a siren on the dashboard has put up that there is something malfunctioning is going on. So when we cut off the power, there is one good thing is that the temperature will not move further, and it will be either lower down or it will be cut off. So while we our engineer will visit it on the place while this kind of the alarm, because this will choke all the system, and it will make a safe operation of our operators also. You heard about this fire incidences on the electric vehicles or electric batteries especially. So this is in the absence of these safety features. We put some of the safety features to cut off, and that pop-up has been goes on the dashboard, and uh, while a service engineer has visited, then it will take out the or doing the bug analysis what the bug is in, either the battery has gone on the higher temperature, or so this is one of the safety feature we have provided. In the field of the controlling the temperature while we are drawing the currents or the energy from the battery, this is one of the area where research and development is required to further reducing the risk while we are putting the foils and then electrolytes and then the separator. So a good research is going on to reduce the temperature, and maybe in coming year we got the good solutions so that the temperature will not cross at least 80 degree to 100 degree. It will be remain as low as possible to make it the safe operation.
Thank you, sir. Thank you. Can I have another question?
Yeah, please.
Yes, sir. That's actually to provide EV charging infrastructure is naturally a challenge. And I want to know what are your analysis that how government should support these EV charging infrastructure so that it can support this wide adoption globally.
Yes, this is one of the major challenge in the boosting purchase a gasoline operated vehicle. They will not think twice because they have the enough petrol pumps is available on the highways or on the state highways, or we can say on the between the villages also. So there are very proven infrastructure is already established in the field of the gasoline stations. If EV need to be boosted up like a multifold, then first of all, the we have 10 folds of the infrastructure is required to guarantee that nobody will be stand up or either they have a PHEV vehicles. Basically, they have to purchase the HEV vehicles. Why we are purchasing the HEV vehicles? Means a hybrid kind of vehicle, because we are not so confident that our vehicle will not stuck on in mid of the road or mid of the journey. So in my view, first and foremost, the GST has reduced to the from 18% to 5%, but that is the penny. We can say penny kind of a very small action has been taken. If it is really boost up, then the subsidizing the youth for establishing the electric vehicle and guaranteed that they will get the business, that will be helping a lot. Meanwhile, on the they have the passed the one rule that every gasoline station required to have a fast charging infrastructure. That will be boost a lot because we already having the gasoline stations like petrol, diesel is everywhere. If this rule will be implemented and they bound to have a electric charging stations, so we need not to be innovate something from the scratch. We are having some of the infrastructure and we will use this infrastructure. So this is one of the particular one of the good decision which Indian government should take.
Thank you, sir. Thank you. I think, sir, smart grid integration could be one of the solution for
Yes.
widespread availability. And naturally, as you said, faster charging stations are needed because whenever we are adopting new technology, then availability is naturally an issue whenever we are away from these stations.
Yes, you're right.
Thank you, sir. Thank you.
Thank you.
Thank you, Rajesh sir. Uh, any other participant, if you have any question, please come forward. I think no more questions. So thank you, Ali sir. Really, it was very informative session. And now I would request Dr. Amit Bahekar from Mechanical Engineering Department for vote of thanks. Amit sir.
Thank you, Satya. Am I audible? Thank you very much, Ali sir. Thank you very much. There was very nice informative session. You are very wholly explained that the EV market in India. I have seen that slide. EV market in India, EV market outside in India. That is the one challenges of the EV in India. One challenge is I very like that less charging stations still are available in India. Then so people are very afraid of that purchasing the EV vehicles because of that. So also you have very nicely explained the India's car market with the graphical representation, and at last that benefit of EV over ICE engine. That you are very nicely taken the points of the comparison between the EV and ICE engine. So it was very nice session, sir. Definitely, I request also Satyan sir to conduct such session in future also, so that our students and other also take the advantage of this. Thank you very much, sir, for spending a valuable time. Thank you very much.
Sure, sir. Also, we would request Ali sir if we can have some offline session as we are very nearby Pithampur. If possible,
Yes, yes, yes. And there will be a good connect between the audience and myself because while I have started my presentation, I'm not able to see and connect with you. I'm quite
exactly.
discomfortable in between because I don't see you physically. And in my screen also, I am just having my presentation. So I am just worrying that is it me who is
Exactly.
delivering and listening? So yes, definitely. And
Sir, sir,
in
your
the
session was very useful, very informative.
thank you, Ji. So in the offline, one thing is very good. The question comes very often because only 3 and 4 questions is
Correct.
there. Okay, thank you. But in the offline, because a person is standing in front of you, and then you ask by any means before they leave actually the place. So yes, this is one of the good interaction with you guys. Uh, you all are from the research and development background, from the academia. We are from the industries, and we have a good tie-ups with IIT in SGS, ITS, IDV, DAVV, IE. So we all also oftenly meet the academic people only everywhere. When we interact with the academic persons, we encourage them that whatever you are doing right now is not using tomorrow. It will be used after day after tomorrow. It
Correct.
will be definitely used in maybe in 2030. So whatever your research, whatever your development is going on, so it will definitely serve the nation maybe after 5 years or after 10 years, but then definitely it will serve the nation. So you, thanks to all of you, Sage University team, to invite me on this topic. And if you have any query, so please let me know. I'll put my email ID and number to Satyanji. So
Yes, sir.
definitely you may contact for further inquiries.
Sure, sir. And we would like to visit your plant also,
Yes, yes,
along
please,
with the
please,
students.
please,
Yeah.
please, sure. Because this is one of the area where we are working very closely with our human resource team. We invite the academic persons. Last time, some of the professor from IIT, along with Mr. Professor Chatraj, is coming and visited the place. And because nobody knows that is one of the bad thing about my organization. Nobody knows that in Pitampur there is one industry who is working and who is serving the 120 countries. That is
Oh,
one of the good landmark that our product of the loader backhoe is spreading not in all over the India, but it's all over the world. So this is one of the good facility. And being an MNC, we are adopting new technologies, new benchmark process at all over. So it's a world class and cutting edge technology we are using, because India can grant it for us, but world cannot. So
right, sir.
we are using really we can say world class product here from here, and it will be goes with the very crucial eyes.
Right, sir.
Thank you all, and thank you Sudhanji, and thank you Sachin. Thank you.
Thank you so much, sir.
Thank you, sir.
Thank you. Thank you. So, with this, I think we are now closing this first session of today's. Now, moving to second session, as our second speaker has already joined, Dr. Devendra Verma, sir. Sir, are you available here?
Yes, yes, I am available.
Yeah, sir. Sir, good evening, sir.
Good evening.
Good
I am
evening.
audible. No?
Yeah,
Good
sir.
evening. Good evening.
Yes, sir. Sir, let me make your ID co-host. Just a minute, sir.
Okay.
First of all, I would thank you, sir, for sparing time in evening time. For
It's
whole
my
day, you
pleasure.
are already in teaching, and after the day, I asked you just for joining. So, thank you, sir. Before starting the session,
Thank you, Ratan, for inviting me for this special lecture. Thanks a lot.
yes, sir. Before starting, I would request Dr. Amit Bhai, sir, for welcoming, sir. Amit, sir, over to you, sir.
Yes, sir. Yes, sir. Am I audible, sir?
Yeah, yes,
Uh,
sir.
Yes, yes.
sir, on the behalf of Sage University, Department of Mechanical Engineering and Department of Advanced Computing, I heartily welcome Dr. Devin Verma, sir, to our third day of the
Thank you.
FDP. Heartily welcome, sir. Heartily welcome.
Thank
And
you.
thank
Thank
you
you.
very much, sir. You are sparing the time in the busy schedule. I know that whole day is busy with the other task and this work. In spite of that, you have
Obviously,
taken
in
the
the
time.
university, we are having all of us having so much time, so much work to do.
Yes, sir. Yes, sir.
So we all are busy, and yet all
Spite
are
of
gathering over here to discuss certain new things, which is quite appreciable.
Yes, sir.
Yes, sir.
In spite of that, you have make the time. Thank you very much, sir, for joining us. And definitely, today's topic of the sir is the quality development in the electrical. So definitely, this topic is very popular and helpful for our research area, for project work, and for the further publishing the research paper. So all participants are requested to listen carefully, note down the things, and clear their doubts. So carry to Devan Verma, sir. Please start your talk.
Sir, before that, I request Professor Gautam Singh, sir, for introduction. Gautam, sir, over to you, sir.
Uh, Good evening, everyone. It is my pleasure. It is my pleasure to introduce our esteemed speaker for today's session, Dr. Devin Verma, sir. Dr. Devin Verma, sir, is a professor in the Department of Mechanical Engineering at the Institute of Engineering and Technology, IET DAVV, Indore. He holds PhD in Mechanical Engineering from DAVV Indore, along with PG degree in Industrial Engineering and Management, MBA in Marketing, and BEE in Mechanical Engineering. With over 14 years of teaching experience at the undergraduate level and 11 years at the postgraduate level. Dr. Devin Verma specializes in industrial engineering, quality management, operation research, and manufacturing processes. He has published over 42 research papers in reputed journals and has guided numerous postgraduate dissertations. His session will provide valuable insights into the application of quality function deployment in electric vehicles, focusing on how QFD can enhance product design, customer satisfaction, and innovation in electric vehicle development. Now, I request to Dr. Devan Verma sir to kindly begin the session. Over to you, sir.
Thank you, Gautam. Thank you. Very good evening to all of you, all the
Good evening, sir.
participants.
Yes.
I'm audible, clearly audible.
Yes, sir, yes. Perfectly.
Okay, now uh, before starting the session, I would like to say I will try to link the previous session as well as this current session of mine. Ali Asgar sir has already told you regarding the market, electrical vehicle markets available out in India as well as the outside India. So, as we know that every product which has been manufactured and it has to be manufactured for the customers. For the potential customer, the segments which has been identified by the companies and to cater the need of the segment, the company used to develop the products. Electrical vehicles or automobiles which is used by which is done with the help of the conventional fuels. So the thing is that whenever we have a product, is that whether it is of any kind, whether it is electrical vehicle, electrical autonomous cars, or some other products, we will have to provide, we will have to generate the market shares. We have to gather the market shares so that the customers can maximum the customer can purchase our product as well as in turn the company will generate the profits. है ना? So whenever we are having we means the companies are having the objectives, the motive to maximize the profits. Obviously, we will have to go for the provide the good quality product to the customer. So as we know that the electrical vehicles, these are new upcoming vehicles which are nowadays the demand of the society, environment as well as the demand of the industry. So we will have to, whenever any organization is going to manufacture an electric vehicle, it has to be provide quality product because we want to uh, we means the companies want to sell the products to the target customers. Isn't it? So how the quality can be deployed within the electrical vehicles has to be this is the key question or key research area nowadays. So quality function deployment is one of the tools which we can use to impart the quality in electrical vehicles also. Conventionally, we normally used to go for the electrical apply the quality function deployment in so many areas, not only in the manufacturing sector, but also in the service sector also, like in hospitals or like in hotels, and designing any product, any automobile or any electrical product or anything which is any product which the customer is going to purchase, the customer is going to buy. So basically, whenever we go for the quality product, as Ali Asgar sir has already told us, this is the so many broad area market is available in India as well as outside India. So every organization has to compete, has to make a good quality product or good product, whether it is electrical vehicle or other, so that the customers can purchase our product into our product. So to meet with the competition, to meet the global demand, to meet the global competition, every organization has to go for the good quality electrical vehicles. As we think that, as we are, why we have already heard so many things in the newspapers that is such type of product is there, electric vehicle is there, which is being blasted because of the battery failure or because of the some other reasons, or the most frequent problem that is that electrical vehicles nowadays is facing the charging stations as well as the battery life. How much time the vehicle will run for how much particular kilometers, as well as the electrical vehicles are concerned. So all these are the attributes which are used to be gathered or to be catered at the time of the during the design stage of the product. So with the help of the quality function deployment, this particular tool is basically used for it's a tool of industrial engineering and management, and then we can implement, we can use this particular tool. So my session will, I will have a small case study related with the uh, deployment of the quality in a electrical autonomous car. See how a particular car has to be is there, and how those features can be gathered from the target segment, target of potential customers. How do these parameters, those voice of customers or the requirement of the customer will be catered into the converted into technical parameters, and those technical parameters will be converted into the part characteristics, and those part characteristics will be converted into the subsequent process parameters, and after that process planning of that. So throughout designing stage, right from the design stage to manufacturing stage, we will have to have a series of steps to be followed to get a good quality electrical vehicles. So now I would like to share my presentation to all of you. I think this introduction is sufficient is there for you for just to get convinced, just to get make awareness regarding what the quality function deployment is and how it should be converted, how it can be used. Now, in my presentation, I will show that how this could be implemented. Okay,
Yes,
I'm sharing
sure.
the screen. So, is the screen is visible or not?
Not yet, sir. After sharing, you need to click on that particular screen, which part of your desktop you want to share.
Okay, okay, okay.
Yeah.
First of all, I will have to share this, na application window.
Yes, yes. First click that and then click share.
Okay, yes.
Yeah, yes.
Now it
Now.
is okay. Visible?
Yes, sir. Yes, sir. Now it's
Yes, sir.
visible.
Visible, sir.
Visible, na?
Yes, sir. Yes, sir. Perfect.
Okay. the topic of my today's session is application of quality function deployment in electrical vehicles. So first of all, what is quality function deployment is? Basically, it is a technique which uses the voice of customers as the inputs. Voice of customers are, we can say that the voice of customers means the requirements of the customers. Those requirements of customer will be gathered with any means through the customer, through the surveys or the interviews or through direct communication between the target customers and those customers' requirement will be converted into or translated into the customer needs or into engineering application. सत्यम इसको मैं मिनिमाइज कर दूं क्या है ना कैमरे ठीक है
Yeah, yes, sir. No issues.
ओके ओके नाउ whenever whenever we say quality product first of all what does it mean? It means the product should be in conformance with the customer's requirements. Whatever the customer's requirements are there, if the product is fulfilling those requirements, that product is said to be the quality product. Okay. Now, quality function deployment means how we are going to manage the quality within the product. What are those key features, parameters are there, which has to be there in the product so that product can be said to be quality product. So, quality function deployment is a basic tool which can be used everywhere. Now, it can also be used in electrical vehicles also because means we have to identify the customer needs, translating those customer needs into the engineering specification. This particular tool uses the house of quality model, which is basically have a correlation matrix between the customer's requirements, technical parameters, customer competitiveness, and the target value. This house of quality, which is the outcome of the QFD, gives us the correlation matrix between the what customers is required, how those requirements can be converted into technical terms, and what the competing brands are doing on those parameters, and what is our status right now, and what should be the target value of a specific technical parameter so that it can be increased. So this is the whole approach can be used for getting the good managing the quality within the product, right in the design stage to the production process planning. Means how it could be implemented in electrical vehicles. Basically, it is being applied to electrical vehicles to prioritize actions and policy related to handling spent EV batteries. Means whenever we are having the major issue in an electrical vehicle is that the EV batteries, electrical vehicle batteries. So electrical vehicle batteries is not only it is only a single one of the attribute which can be. So many other attributes are also there that can be prioritized in the electrical vehicle so that the product can be treated as a quality product. That product which is basically it is electrical vehicles in nature. So apart from the electrical vehicle batteries, other parameters will also be there that has to be identified. Those some important ratings to assign to them, and then we will be having some measurable technical descriptors that can be used to just change the modify the existing electrical vehicle or designing altogether new electrical vehicles. The very first thing of PFD methodology is the house of quality that I have already discussed with you people, that it has got some voice of the customers in terms of the vows, wants, must, like this. And these words has to be converted into design attributes, which is known as house. ठीक है कि कस्टमर की रिक्वायरमेंट है कुछ that requirement may be raw in nature है ना. For example, the customer wants that the battery should be long lasting, the mileage should be more, So that mileage should be more will means like the battery he need not to uh, recharge the battery again and again in small by traveling a small distances. So what we will have to do, we have to convert those that raw requirement into technical design attributes. Like we want to convert that technical, we want that convert that raw data into the technical attributes that the battery should be long lasting. It has to be, it should not be discharged again and again. It should be discharged after a specific period of time. And that time should be that time should be high. So these things could be identified, and obviously, such of course, the customers will convert into technical parameters. So basically, whenever we are going to implement a TFD, it has got four stages. First of all, the customer needs to translated into these design requirements, which are then translated into critical part characteristics. These characteristics are translated into critical process parameters, and finally, the process parameters are translated into the process and quality control for the product. Means right from the design stage to the manufacturing stage, we'll have to implement that. This is what the beauty of quality control deployment is. It is not only it is not only start with the designing stage, but it has to be there throughout the whole stage, right from the design stage to the manufacturing stage. It has to be there. And different modes of application are some matrix approaches are there, which is normally used to convert uh, the first thing is that is a the design customer needs are translated to design requirements. First metrics will be formed just like this. Then the design requirements will be converted into part characteristics. Those part characteristics will be converted into process parameters, and process parameters will be converted into the process and quality control. So these are these different different methods we will have to prepare to get the managed quality right from the design stage to the manufacturing stage. Okay, I am audible now.
Yes, sir.
Yes, sir.
Okay. So whenever we are going, if we want to implement the quality, the QFD in electric vehicle, so first of all, what we will have to do, the very first step is to that we will have to identify the key requirement of the electrical vehicles. See what the customer's requirements are there, which has to be which has to be incorporated in the electrical vehicle, because we want what is our objective? Our objective is to provide a good quality electrical vehicle. Now, n number of brands are available, but we want to have a cutting edge of for our brand. We'll have to provide the quality in the electrical. And as we know, there are n number of electrical scooters are available. We normally used to see in market. Okay? And all those are having different design specifications. So, n number of competing brands are available. We have to compete with those brands. Obviously, we will have to go for good quality product. So, very first thing is that the identification of the customer's requirement. Now, how those customer requirement can be get that? वो कैसे लेंगे हम? So these can be obtained. Customers input can be obtained through surveys. Those surveys can be with the help of the questionnaire, or it can be with the help of questionnaire which has to be responded by the target customers or the potential customers. And directly we can fill that, or we can send a Google form to the n number of customers to identify the customer's requirement. Now, those customer requirements will be correlated with the help of the technical descriptors, because the requirements of the customers are raw in nature. They are not, we know that the customers are not technical in nature. It is not necessarily every customer who is using the product is having the technical knowledge of regarding the technical knowledge of the product regarding the product. So we have a raw data, we have the raw customer requirement. Now we will to correlate those raw data into the technical descriptors. Okay? So that it can QFD will be it starts from the product design. Okay? The product design is start over. QFD will start with the product design and those customers requirements which are realistic in nature will be priority. Those demands which are realistic in nature, those customer requirements which are realistic in the sense, realistic in terms of the technicality. No, realistic in terms of the whether the product, those requirements can be converted into technical terms or not. So many raw, absurd requirements can also be there from the customer's point from the customers. We will have to restrict ourselves from the only those technical requirements which can be converted into technical. We can convert it technical. Now, after getting the customer requirement, we will have to go for assigning the importance of the rating, customer requirements. This one is the critical step. N number of customer requirements, we have got N number of customer requirements, and how now which particular requirement has to catered first. This is the one thing. Obviously, by
Yes, sir.
N parameters are there. N parameters, this particular parameter is to be addressed first of all. This has to be, we will have to go for the prioritization of the attributes of the customers, first of the customers, so that one by one we can address the customer's requirement, so that we will address. It is quite impossible we can address all the customer requirement at a time. We'll have to go for the by the steps. How it is possible? We will have to prioritize the customer's requirement first. Okay. So assigning the importance ratings to those priority customer requirements. How it is possible? What is the mode? How we can prioritize the customer? So there are so many mathematical models are there. They're like analytical hierarchy process है, या analytical neural networks है, ANN से कर सकते हैं, AHP है. We can have the scatter diagrams are there. We can have the uh, other tools or techniques are there which can be used to identify, which can be used to prioritize the customer's requirement. Depending on, and obviously, prioritization of the attributes will depend upon the resources which are available to us. And we will have to allocate the resources according to the prioritized customer's requirement. So it is not necessary because implementation of quality is not a what we can say. It is not a very less expensive. It is less expensive effort. It is a very much expensive effort. Now it consumes it incurs cost, and we will have to minimize the cost. Why? Because we are having our target segment already fixed. We know the purchasing power, the buying capacity of the customer. So obviously, we will have to provide the quality as per the buying capacity of the product, of the customer. Obviously, if it is not possible, then what happens? If we provide a high quality product with higher cost to a particular segment, it may be possible that the customer will not prefer that because it is beyond the purchasing power of the customer. So whatever the objective is that whatever the amount of the customer is willing to pay for our product for the quality, we'll have to pay. We'll have to provide that much quality. A live example of the nano car has been noted 1.5 lakhs, 1.75 lakhs is sufficient for the good nano car. If the cost of the nano car increases because by providing more attributes in the same product nano car, it may go beyond 2 lakhs, 3 lakhs. So there are customers will not willing to pay that. Will be not willing to pay for that car. Why? Because those n number of other brands are available with same price, and our target segment has changed. We don't want to disturb our target segment. For different target segments, we are having different products. Okay. So we have once we have prioritized the customer requirements, those prioritized customer requirements will be converted into technical parameters. So these technical list parameters or the technical descriptors are those parameters which are related with the customer's requirement, which is we have already prioritized. So technical descriptors are basically it is in correlation with the customer's requirement. Okay. So whenever we are having the prioritized customer requirement, it has to be converted into technical descriptors because टेक्निकल डिस्क्रिप्टर्स को हम बोलते हैं इंजीनियरिंग स्पेसिफिकेशंस या वॉइस ऑफ द इंजीनियर्स. जैसे कस्टमर रिक्वायरमेंट्स आर द वॉइस ऑफ कस्टमर्स, वैसे ही टेक्निकल डिस्क्रिप्टर्स आर द वॉइस ऑफ द इंजीनियर्स बिकॉज वी आर as an engineer we are converting the customer's requirements which are raw in nature, which are non-technical in nature. It has to be converted into the engineering specification or technical description. Clear? Means we are having these technical descriptors are provide us the tangible way to translate the customer's needs. Okay, how much amount is to be, how much change is required into the technical parameters so that the customer's requirements can be fulfilled. ठीक है ना? So whatever the customer expectations are there, it has to be converted into technical descriptors, which is quite measurable, which is engineering in nature, and which can be modified by using the engineering applications. Okay. I think all of you are comfortable with this particular topic. All of you are getting the things that I am explaining to all of you.
Right, sir. Correct. Yes, sir.
Okay. Thank you. Now, one thing is that whenever we go for the talking about the technical descriptors, obviously what we should do, what type of technical attributes are there that must be present within the product. So one model is there which is known as Kano model or Kano analysis, which was developed by Dr. Noriaki Kano in 1984. They have developed a model which basically gives the relationship between the customers various relationship of the various features which has to be there in the product, and it also explains if such type of parameter features are there, what will be the reaction of the customer. Like this particular model is known as Kano model. As we can see this in this slide, it has got two axes, customer satisfaction and dissatisfaction. So some certain features are there in this model that a product that the product should have. Means some features of the product are comes in the category of the must have features. The red color. This red curve is showing the must have characteristics. Means every product should have these features in the product. Whatever, depending upon the nature of the product, the must have characteristics may be different. For example, for a mobile phone, the feature is that you will have to be able to communicate with the other person, or we can access the mobile, we can access the internet, we can access so many other things. So these are the must have characteristics, must have attributes, which has to be the presence of these must have features will not since it is what we can say, since it is already expected, this is the by default features are there, it has to be there. So presence will not satisfy this person. The presence of these features will not satisfy the customer, but the absence of these attributes will highly dissatisfy the customer. Understand or not? Means यदि ये पैरामीटर्स नहीं होंगे तो कस्टमर्स बहुत डिससेटिस्फाई हो जाएगा, लेकिन यदि होंगे तो इट विल भी ठीक, वो बोलेगा कि नहीं ये तो होना ही चाहिए, दिस इज द बेसिक, दीज आर द बेसिक फीचर्स। हम बोले कि बेसिक फीचर ही नहीं है तो क्या मतलब है ना। दिस एज ए कस्टमर, यदि हम कोई प्रोडक्ट खरीदते हैं एंड इफ वी फाउंड दैट की some basic function features are not functioning, तो हम बोलेंगे यार व्हाट इज दिस। So these features must have parameters are there, which are there that has to be present. ठीक है, some of the parameters are there which are linear in nature, performance wise. This one, these are the linear attributes which shows the performance of the product. If these parameters, if these some functions, some functional features are there, if it is doing, if it is doing, the product is doing the work according to the customer's requirement, so so the customer will be fully satisfied. And these type of features are known as linear features, or we can say that linear attributes. These are the linear attributes because the it increases the satisfaction level of the customer. Yeah. The orange one, the orange curve, this is known as exciter. इसको हम बोलते हैं excitement attributes. Orange attributes are known as excited attributes. Means those attributes which are not being expected by the customer, but we are providing those expectations. Customer has not expected such things, but the product is having such other attributes. The customer will get delighted, and in delighted he will be more satisfied with that. Okay. This the orange one. This curve is known as reverse curve, है ना? Which happens which shows the dysfunctionality of the system of the product. If the product has got n number of features and product become complicated, then what happens? Because of the complexity of the too much complexity in the product, the customer is not able to use that. This will show the reverse satisfaction, or we can say dissatisfaction will be there. So these are the categorization of this. These are the categorization of the attributes which has to be present in the customer. So whenever I am just giving you a simple example of the customer delight, that if we are having, if we have booked some hotels or some tour travel plans to somebody, to some place with the on Make My Trip or on some other traveling partners, and we have booked a certain level of a hotel, 3 star, 4 star, but on the same price, if the company, the traveling partner has upgraded our hotel from 3 star to 5 star, from 5 star to 7 star, which is not being expected by us. This is what the customer is delighted. With the same price, with the same package, if we are providing extra attributes, extra features to the customer will get this, will get the highly satisfaction level. So this basically these things will give us, this Kano model will provide us the satisfaction dissatisfaction level with us. So a rating of satisfaction dissatisfaction has to be achieved, not only in product, but it also will be there in the electrical autonomous cars also. Okay, or electrical vehicles also. So these are the attributes, must be attributes, attractive features, one-dimensional features, है ना, reverse features जो हमने बोला, questionable features are those questionable features, means those the features which are there and customer are unbiased with that. क्या ठीक है सर, कोई फीचर हाँ है तो ठीक है, नहीं है तो भी चलेगा. Some features are there which are there which can be, and the customer will not will be unbiased with that. The presence or absence of those features will not affect the satisfaction level of it. Reverse features we have already discussed. One-dimensional features, or one-dimensional features, we have already told to you that one-dimensional feature means the excitement level, the exciting features, apart from the must be or attractive features, one dimension features are those parameters which has to be there just to in the product just to what we can say, just to get the eye of the customers. Because we want to separate our product from the competing brands. Okay. So these five active types of attributes should be there in the product. Now, how this analysis can be used in the electrical autonomous car? This I will tell you. So first of all, we can have the identification of the feature. What should the features are there in the electric autonomous vehicle, electric autonomous car? The features are like this. Is it audible? Is it visible to all of you?
Yes, sir.
And
15
audible
features.
also?
Yes, sir. Yes.
Yes, 15 features are there, which has to be there in an autonomous electric car. Autonomous electric car means some advanced version of electric vehicles, like which has been manufactured by the Tesla and other big organizations. ठीक है ना? AI voice board. That is, now these are the active features. AI voice board means interactive voice responding system, vehicle to vehicle communication, which connects with other vehicles for safety purpose. Biometrics used for unlocking the car. Face security system used for starting the vehicle. Mobile connectivity app used for checking the status of our autonomous vehicle. Light detection and ranging. Now, LIDR means used for the distance determination, object identification, street sign recognition, identify road sign, microphones, grid charging. Now, grid can be charged when the vehicle is not in use, adaptive cruise control, now, regenerative braking, strong box. So these are the features which has to be there in the autonomous electric car. So we will have to identify these are the 15 features are there which has to be prioritized and it has to be encountered in the which has to be encountered during the subsequent designing stages of the autonomous electric car. Then a curtain airbags, safety airbags for side windows, dedicated storage space, enough space for storing and belongings. So these are the features that has to be there. Now, how these features are there? How these features can be rated? हमें इसका इम्पोर्टेंस रेटिंग निकालनी ना. We want to identify, we want to calculate the satisfaction and dissatisfaction level of the customer by having certain type of activities with them. So we can have a small we'll have to go for some small survey. So as per the Kano tool, we have provided two choices to the customers. One is functional, means those attributes which are being provided in the products, and this function means not provided. Means whenever we ask the customer means the potential customer, the person who is willing to purchase the product. So we will have floated a questionnaire to them, and then we have given the two choices in terms of the attributes. One is the functional attributes, that is those attributes which are already provided in the product, and another one is the dysfunctional attribute which is not being provided in the product. Okay. The respondents that we have got from survey with the available option given for each product, these are the responses. The relish it means if functional attribute है, तो relish मतलब क्या होता है? Relish means enjoying the attributes or not enjoying the attributes. Necessary means attributes are necessary, must. Unbiased means the presence or absence of the product of the feature is not affecting the customer's satisfaction level or dissatisfaction level. What can live with it means if some functional attributes there, we can use that or we can not use or avoid it. So these are the 5 points that we have identified, and customers, the respondent has told, we have told the respondents to just give their response in terms of these five parameters. Sorry. Now the data has been sorted, and we have find this particular matrix for. The responses are categorized in relish, it necessary and bias, can live with, avoid it, and on column side relish necessary, and we have just we have just mapped the responses with the response of the customer. जैसे relish है questionable, I mean questionable मतलब it is not, some of the respondent has given this questionable response, means that the customer requirements that are was not was very vague, or we can say or not can be or cannot be converted into the technical parameter, है ना? Necessary, attractive, one dimensional, reverse. So these are the functional parameters, these are the dysfunctional parameters. So on the basis of these uh, responses, we will be able to identify how much responses are there for the attractive features, how much for the indifferent feature, how much for the must-have features, and how much for the reverse features. As a customer sample survey in which customer has filled out the responses, relish, since he is sure that he wants the feature provided in their vehicle. Similarly, if the feature is not provided, customer has listed the responses unbiased, or not providing the feature. Decreasing, in order to decrease satisfaction, the customers can choose relish it, necessary, unbiased, can live with it, or avoid it according to their choice regarding particular feature. So we have got that. For example, I have taken only first one feature over here, AI voice bot, the first attribute, interactive voice recording responding system. If it is provided, the customer will relish it. If it is not provided, biased. Means n number of customers has given the responses like this. So depending upon the various categories, attractive, one dimensional, must be, indifferent, reverse, questionable, we are having different types of, we are having different parameters, different attributes, and with the help of these particular attributes, we will be able to find out the satisfaction level of for the this particular feature, AI voice mode. For example, in AI voice mode feature has active responses as attractive, which is the greatest number of responses among the rest of the attributes. Hence, the final choice stands at A. Here. So the result that we have got from the different from the survey of from the customer survey, we have got such responses. AI वॉइस बोर्ड को 18 रिस्पॉन्सेस में ए बोला, अफेक्टिव बोला, 7 ने वन डायमेंशन बोला, एक ने मस्ट बोला, 13 इंडिफरेंट बोला, रिवर्स में क्वेश्चनेबल बोला, तो टोटल 40 रिस्पॉन्डेंट्स से हमने ऐसा किया है. तो हमने ऐसे कैटेगरी सिंस द वी हैव टेकन द मोड ऑफ दैट, so we have got categorized that AI voice board has A category, vehicle to vehicle में मैक्सिमम क्या है 12 है, आई मैक्सिमम क्या इंडिफरेंट, तो हमने आई की कैटेगरी दिया, सो एंड वी हैव गॉट such type of categories. So the first one is AI voice board is A category is attractive, others vehicle to vehicle, biometrics, face recognition, mobile connectivity, these are indifferent. Indifferent का मतलब क्या है? Indifferent मतलब कस्टमर आर अनडिसाइसिव, अनबायस्ड, होगा तो ठीक है, नहीं होगा तो भी ठीक. They are not having so much age, they have not responded so much. What they have even not didn't think of that such type of things should be there. So their responses are dicey in nature. Okay, indifferent nature. Obviously, before going to implement the quality person deployment, we'll have to go for all these exercises. We have to categorize our features, the different features and like this. This is I have already explained to you. I am skipping this. Sorry. Now, depending upon this, the responses or satisfaction level, depending upon this, we can find out, we can prioritize the customer's requirement. These are the voice of customers that and important rating we have assigned. Autonomous driving quality reliability on a past 5 rating, fast battery charging 4, travel time should be less 3, obstacle avoidance, user friendly interface, more boot space, and efficient safety system. We are having such, these are the customer requirement and we have assigned the ratings to them. Okay.
Excuse me, sir. Sir, these ratings will be provided by customer only.
Right, these ratings will be given by us. Now, we will have to provide the important rating. Now, means having before going through these particular things, we'll have to identify the customer satisfaction level and dissatisfaction level.
Means these are
Okay.
like weightage.
These are the weightages. Okay.
Which
So customer
parameter?
satisfaction level, depending upon the customer satisfaction level, actually I have skipped that particular slide in that because it was too much technical. See, whenever you go for the things like this, this one. If I am talking about the AI voice boot, है ना? So we will have to we have calculated the customer satisfaction level for that, which comes out to be 0.75. So 0.75 आया तो हमने उसका तो भी वेटेज ज्यादा था इसलिए हमने उसको 5 वेटेज दे दिया एंड सब्सिक्वेंट satisfaction level के basis पे we have assigned the importance rating to it.
Okay, sir.
Means for example the next is fast battery charging. तो fast battery charging का जो customer satisfaction level था वो था 0.77. तो हमने उसको we have assigned rating 4.
Okay, sir.
Travel time should be less का जो वेटेज था it was then 0.69. तो हमने उसको वेटेज का असाइनमेंट 3 दिया.
Around
Obstacle
30.
avoidance का rating means in this way we have assigned the ratings, importance rating according to the customer satisfaction level. Okay.
Okay, sir.
Now this. Now this is the table number 5 shows the second step. Whatever these are the prioritized customers requirement, autonomous driving quality, fast battery, है ना? Now we have to convert it those customer requirement into the technical descriptors. How autonomous driving quality and reliability can be achieved. So this matrices shows the technical descriptors or technical. ठीक है ना? LIDAR, GPS navigation, because autonomous driving quality reliability means we want that the car is autonomous. It has got the ability to drive selflessly. ठीक है? So it has required the laser detection, light detection, and other traffic environment with that. GPS navigation is also there. So we have converted these customer requirement into the technical parameters. Fast battery charging time means it is related with the better management, battery management system, grid charging, etc. So this has to be done. This has to be converted. Customer requirement has to be converted into matrices. Then obstacle avoidance, LIDR and different types of sensors nowadays because vehicles are having. So since we are talking about the autonomous electric car, so we want to have the LIDR, DR as well as this different sensors that will be able. So sensor will be able to detect the different obstacles and providing the alarm or warning to the driver, or selflessly it will auto-driven car is there. It has to be done by the car will stop immediately or will change its route or change its track depending upon the uh, whatever the environment, whatever the nature of the obstacle is. User friendly interface. So we will have to have certain type of algorithm, more boot space, means the classification of vehicles, number of seats, etc. These are the certain technical descriptive parameters which has to be incorporated in the product just to meet these customers' requirements. Okay.
Okay, sir.
Next step is impact of material on customers' requirement. How this matrix shows the relationship between the customer's requirements and the technical parameters. Means we will have to assign the weightages. See how much a particular technical descriptor or technical parameter or the part parameter is correlated with the customer's requirement. So we will have to assign the weightages. So the if I am assigning 9, it is strongly, it means that it is strongly uh, related with each other. 3 moderate, and 1 is the least correlated with each other. मतलब if I am providing one point to a particular to a combination of particular uh, parameter and technical descriptor, for example, algorithms and the table time. I have assigned this one. Means there is a weak relationship between the table time and the algorithms. And if I am assigning the battery management system with autonomous driving quality system को 3 देना मतलब it has got a moderate relationship. Battery management system past battery life I am assigning 9 point. It means that it is highly correlated with it. So impact of materials on customer requirement, this shows that how strongly a particular quality parameter customer requirement is related with the technical parameters. So this shows that actually what is the why we are doing this particular thing. Basically, by assigning the weightages to different technical parameters and the customer's requirement, we are simply converting this value into the qualitative term. Quantitative term हम convert कर रहे हैं. We are converting this value into quantitative terms by assigning the weightages. Okay. So depending upon the expertise, depending upon the team, quality development team, we will be able to make a relationship matrix with between the customer's requirement and the matrices of the customer requirement and the technical parameters. Like now, in table number 4, we have assigned the importance rating. ठीक है ना 5, 4, 3, 4, and in table number 6 we have assigned the weightages. Table number 7 we give us the percentage importance rating. Since we are having the importance rating 5, 4, 3 of different quality, different features, percentage importance rating निकालेंगे हम. इनका कैसे निकलेगा ये?
5.
How much number of, है ना, how divided by the number of respondents हम निकाल दिया, तो we have got the this. ठीक है. So we have calculated this value, this importance rating, and then after that we come up with this total score. For example, LIDA, light amplification driver this particular feature, it has got value 299.91. This is the total score. GPS navigation 253.27. So we have got the weightages and we have got the different total score for all technical parameters, because these are the total parameters. These are the total score of the individual parameters with respect to these customers' requirements. Clear?
Yes, sir.
Now, this is one phase of one middle segment, one phase of the quality function deployment. Okay. Means अभी तक हमने whatever we have done till this point of time, we have just our customers' requirement and our technical parameters. Now, on the basis of these customer requirements that we have already identified, we want to compare these customer requirements with the competing brands also. ठीक है. So So we are having, say, our product, then some other products also, Tesla or Oni.ai. We are comparing our product, the importance rating of our product and the other competing brands. Okay. So this particular data we will have together. We will have together through with the help of the primary data collection. ना primary data हम collect करेंगे, then we will be able to find out what is the status of the competing brands on these customers requirements. Clear?
Yes, sir.
Okay. Now the final step of house of quality, yeah, how this particular thing will be done like this. These are the customer requirements. These are the important ratings that we have already finalized. These are the technical descriptors that are there, technical parameters. These are the standing of the competing brands like Tesla and Pony.ai on the same customer requirement. And since we know that 299.91, 253.27, all these parameters are that the total score that we have already calculated over here. ठीक है ना, यहाँ से लिया हमने. Now, what we have to do now? Now, these stars, your solid balls and triangles showing the relationship of strong relationship or the moderate relationship or the weak relationship. Okay. So star will show the strong relationship. The triangle shows the weak relationship, and triangle shows the moderate relationship, and this solid circles shows the weak relationship. So we are having the target values with us. Epsilon, this shows that we don't want to, these are sufficient quantity, we need not to change these two. BMS, grid charging, is the arrow is representing upside arrow showing that it requires the increment. These two require sensors, and sensors require a decrease in decrease in the target value, which means that we will have to minimize that. Then obviously algorithm हमें increase करना पड़ेंगे. So we are having the target value specifically. So these symbols, epsilon, the arrowheads, up, down, upper arrowheads or lower upper heads, lower arrowheads will show the target to be achieved or target to be increased or decreased. The value to be increased or decreased or no changes. The roof of this particular house of quality, this shows the interrelationship between the technical descriptors also. Here in this central matrices, we are having the relationship established between the customer's requirements and these technical parameters. Okay. Now this roof is showing the relationship between among the technical descriptors. For example, हम in case of the automobile हम बात करते हैं कि we want to increase the mileage of the engine. Obviously, if we are going to increase the mileage of the engine, the power will be decreases. है ना? This is the conventional. I am talking about a conventional two-stroke of force करेंगे. कि आपने power यदि mileage बनाएंगे तो power कम हो जाएगा. And vice versa. There is an inverse relationship between the power. So this relationship shows that mileage and power are interrelated with each other which is inverse in nature. So we will have to establish the interrelationship between technical descriptors also. So this particular table shows that double plus shows strongly positive, single plus slightly positive, blue slightly negative, 1 minus is slightly negative, and 2 minus green is the strongly negative. So we have to establish the relationship between all the tactical descriptors will be related with each other. Means LIDR with the GPS negotiation plus मतलब slightly positive correlation. ठीक है ना? फिर LIDR with BMS negative correlation, slightly negative and slightly positive. इससे so we will have to establish all these things. So a lot of strongly negative versions are there like this. Means this group shows the constraints, technical constraints within the product itself. How much, what is the constraint technically is there, which is not possible for us to go beyond that one. So this technical correlationship will will provide us the nature of constraints, how much value is to be increased, because in increment in one of the parameter will lead to the change or decrement in the another technical parameter. So this has to be avoided. So this we will have to make a trade-off between all these that. And obviously after that we will have to incorporate the quality in subsequent quality in the subsequent stages of the, because this input LIDR, these technical parameters, these technical requirements or the technical descriptors will be input for the second stage of the house of quality, because this parameter will be on this side, and then again we are adding the parameters like part characteristics, which has to be there to get those technical parameters. Those part characteristics will be converted into process planning and all that. So in this way, we will be able to incorporate quality function deployment within electrical autonomous vehicle and obviously in other vehicles also. So this could be the result is that when the attractive feature in this study was AI voice bot, which means that this causes immense pleasure to the customer and they want this feature in their product. In different features such as biometrics, LIDR, microphones will enhance the containment if these features are provided in the product. Matlab, these LIDR biometrics are the must. This AI voice will be it must be it will be in the excitement parameter. जिसको हम क्या बोलते हैं? Excitement parameter को we have already explained that one dimension and attractive features. This one is attractive LIDR and these are the indifferent one dimension. This could be होना भी चाहिए, नहीं भी तो भी चल जाए. ठीक है? Another, the grid charging and regenerative braking has also been an option to consider in terms of electrification. So these two parameters, grid charging and regenerative braking attribute, this could also be taken into consideration during the manufacturing, because it could also be used for can be considered as a must be attribute, or it can be used as an attractive attribute feature, which will be able to attract the customers to purchase our product. And other features like line independence, which is because of the futuristic technology features. जब हम बात करें ना फेस रिकॉग्निशन स्टार्ट करना है गाड़ी को, लाइक ये मोटर ये $15 जो होते हैं ना, लाइक स्ट्रीट साइन रिकॉग्निशन, लाइट डिटेक्शन, ये तो ठीक है. Adaptive cruise control, curtain airbags, dedicated storage space, face recognition system. These are the mobile connectivity. These are the certain features which are futuristic technology in nature. Futuristic technology in nature. Obviously, it will take some time to get incorporated in all the electrical vehicles. So this is what about my session is. I hope you understand that. You have easily. I will be able to explain you easily. Now, I just want to know that if you want to have any query,
सर these
you
ratings में
can
vary
put your
from person to person ना.
just a minute. ना? Yeah. Stop sharing कर लो उसको है ना.
Yes sir.
Okay. Uh, हाँ क्या वो सत्यम?
सर जो ratings हैं these में vary from person to person, means one person is
Yeah,
yes sir.
no, it is not vary from person to person because whenever we are having the the responses that we are having, the responses that we have collected, and after collecting the responses, we will have to calculate the satisfaction level and dissatisfaction level. Those satisfaction level and dissatisfaction level will provide us the importance कि जो ज़्यादा satisfy करेगा उस particular parameter को हम ज़्यादा importance रेटिंग देंगे, जो dissatisfaction ज़्यादा उसको हम less important पे रखेंगे. So somewhere it is quantitative in nature. We are having certain parameter like satisfaction level, and according to the satisfaction level, we are assigning the importance. Although you are telling us right thing, the response of the customer, the potential customer is there. That we will have to just carefully and with the help of experience. So the raw information, raw responses, we will have to just neglect those raw responses, and whatever the true or exact responses are there, we will have to identify them. One more thing is that we are having different statistical techniques, tools are also available with us. With the help of those, we can identify the validity of the responses. That's like T-square test, T-test, chi-square test. We can use those tests to validate our data, collected data, and after that we can use that.
Yes sir, means we can involve statistical methods
Yes,
also.
yes, obviously it has to be incorporated in here because validation of data is must.
Correct sir.
Because in, if you think about ourselves also, if somebody told us, okay, sir, please fill up this questionnaire in the runtime, what we will do, we normally use to go any type of responses to them. For those person, it may be the raw data also. It may be of no use. So he has to be do the statistical analysis to validate the data. Data
Yes sir,
validation is must.
definitely sir.
Hmm. I think my question is over. If any of the participant has any query, please, yeah, all of them are welcome.
Yes sir, we can open question answer session. If somebody has question, please unmute yourself.
Good evening, sir.
Good evening.
So, really, this is a wonderful session. I am Dr. Sharan Shekhar from Sharan Basawa University. I'm speaking, sir. So,
Thank you.
my question is that it's a really, it's a wonderful tool, sir. Concept
Hmm.
rather than tool, it is good concept, quality function deployment.
Yes.
My question is that what is the minimum sample size you will collect so that based on that you can come to a conclusion, sir?
It depends upon the type of the response end. If the response, if our product is like uh, uh, product which will be used by the mass, then we'll have to go for the responses. Some statistical tables are available. We can have the sample size verification with that. Using those statistical table, depending upon 250 or 100, depending upon the confidence level. That is uh, as you know that confidence level means how much data, how much error we are considering. This I am telling the 95% confidence level. It means that 5% of the data I am neglecting. है ना? So depending upon the confidence level, the degree of confidence level, 95%, say 70%, 80%, 60%, we are having the sample size available with us. Statistical tables are already available. First of all, we will have to set this, choose the confidence level. According to that, we are having the sample size. So we can directly go through that sample size, or more or less at least 250 or 500 or 300, depending upon the uh, uh, area of the study. If we are talking about, if we are going for the pilot study, it is okay. We can have the responses of 40 or 80 or 100. And if our area of study is large, if you want more data, we'll have to go for the finding out the exact number of sample size that we can have with the help of the statistical tables.
Sure, sir.
Okay, sir. Thank you. Thank you very much, sir.
Thank you. Anybody else?
Anybody else interested? You can ask the question. I think, sir, no more questions are there.
Okay.
Thank you so much,
Okay.
sir. It's a really very
Thank
good
you.
sample method. Uh, we can also use it.
Actually, Dr. Shahan has also said, rightly said, it is a concept. FDA is a concept. It can be practiced everywhere, not
Yes,
only the electrical vehicles. Since Ali Asgar sir has already given to you have explained the scenario, the market scenario of the electrical vehicle. To withstand
yes,
in the if we are having electrical vehicles to withstand in the market, we will have to provide the quality product. So we will have to go for all these concepts. We will have this concept in the electrical vehicles also. So I think my session will be quite related with your FDP program, I think,
yes,
or
sir,
not.
yes, definitely, sir. Uh-huh.
Uh,
Sir, now
Gautam
I
is
would
also
request.
related.
Yes, sir. Uh,
Hmm.
so now I would request Dr. Amit Bhayakar from Mechanical Engineering Department for vote of thanks, sir.
Uh, am I audible, sir?
Yeah, yes, sir.
Hello.
Yes, sir. Yes, sir.
Yes, sir.
Uh, Thank you very much, Deven sir.
Thank you, Amit.
Very
Thank you.
informative session was there. Basically, this topic is very good for who want to pursue the PhD in the field of that sector, because
Yes,
it is
yes.
data is totally fresh data. Whatever the experiment we perform, it is freshly published. We can publish in a journal. So very helpful
Obviously.
for those students who want to pursue their that research work. So very informative, sir, and very new topic I just learned today. So thank you very much for sparing your valuable time with us, sir.
Thank
Definitely,
you. Thank you.
I also request Satyan sir also, please arrange the sir lecture in our university also to
Sure,
get
sir.
the great opportunity to our
Definitely,
MTech PG students.
I would love to come over Sage University for this.
Yes, sir. Yes, sir.
No,
Our PG students
Thank you,
want to
sir.
listen to you, sir.
no,
So thank
one more.
you
I
very
just
much.
want to say one more thing is that Amit, this particular topic is not only for this research or for the
Uh,
publishing the paper or the getting the PhD degree, but also it can be used implemented in the industry also. We can have a relationship. This is Ali
yes,
Asgar
yes.
Singh has already told to us. They will have all the companies have to implement all these tools and techniques. Otherwise, they will not be able to sustain the market. But if we
Yes, yes,
compare
yes.
the Indian industry and the industry from the US or Europe or Japan, we are nowhere. All the concepts are from the Japanese concepts are there. We will have to implement these things. But since our Indian market is so much big that yeah, we can have n number of customers within the Indian India also. So before thinking for the global competition, we'll have to compete in industry in Indian scenario also. And the companies can generate a lot of profits, lot of market share they can access with the help of by providing quality products, especially in electrical vehicles.
Yes, sir. So, with this, I think we can now come to the closure of this session. Sir, thank you very much, sir, for providing us this
Thank you
time,
very
sir.
much, Satyendra, for inviting me for this particular FDP. FDP. I am also seeing the Gautam.
Thank
after
you, sir. Thank you,
so much
sir.
after long time. Thank you for all the participants who have patiently heard my lecture, irrespective of their expertise or not. Whatever their expertise, your expertise are there, it can be implemented everywhere.
Sir,
Thank you.
Yes, sir.
our participants are interested in knowing your email ID for future
Obviously,
communication.
I will share you. I think you might having my
Yes,
email
sir.
ID. You can share it.
I will share on behalf of you in our group, sir.
Obviously.
Yeah, yes, sir.
Okay.
Okay. Thank you very
Okay.
much, sir.
Thank you, Sachin. Thank you, Amit.
Thank you,
Thank you,
sir.
Gautam, and thank you all the participants for the
Yes, sir.
Thank
Thank you so much.
Yes.
you. Okay.
Okay. So I am now ending this meeting. Thank you, everyone, and we'll meet tomorrow. Okay. Thank you so much.
Thank you.